In this video, we will express vectors in terms of unit vectors and represent vectors in terms of its components. To begin, we need to understand the operation of adding two vectors. As you may already know, this can be done by moving the tail of one vector so that it is at the tip of the other vector. Connecting tail to tip yields the resultant vector. Expressed another way, this resultant vector can be given in terms of the sum of these two vectors. If we have an axis, or anything to measure our vectors on, and in this axis is a vector, r, I can express that vector in terms of vectors that are aligned completely with the axis. R is the sum of a vector on the x-axis, r sub x, with a vector on the y-axis, r sub y. The square of the magnitude of r is the sum of the squares of its components. If I have a third dimension extending into and out of your screen, I can simply add it in as r sub z. It is possible to express any vector in a closed space in terms of multiples of unit vectors. On the coordinate axis, imagine a circle of radius 1. Any vector that begins on the origin and ends on this circle will have a magnitude of exactly 1. Because this vector is pointing completely in the x direction, we label it as x. Because it has a magnitude of exactly 1, instead of using an arrow over the x, we use a hat. This vector is then called x hat. Similarly, this vector is y hat. This is negative x hat, and this is negative y hat. Such unit vectors are commonly represented by I hats for the horizontal axis, j hats for the vertical axis, and k hats for the third dimensional axis. A vector that has a magnitude of 2 lying on the horizontal axis could then be represented as 2 times the horizontal unit vector, or 2I hat. Any vector pointing in any direction can be expressed as a sum of multiples of these unit vectors. 2I hat plus 2j hat, for example, gives this vector in yellow, since it is a resultant of adding the 2I hat vector to the 2j hat vector. Our previous r vector, then, expressed in terms of its x and y components, could be rewritten in terms of unit vectors, where each component is simply some multiple of a unit vector. In this case, the magnitude of r sub x and r sub y, and, if present, r sub z times k hat. The vectors r sub x and r sub y can also be considered as projections of the vector r onto the horizontal and vertical axes. We'll call the projections r sub I and r sub j. Notice that these projections can easily be written in terms of r if the angle between r and an axis is known. R sub I is simply r times the cosine of theta, and r sub j is r times the sine of theta. Adding vectors in unit vector representation is straightforward. Add each component individually. Adding vector A to vector B, as shown, means we add 3I hat with 5I hat, and 5j hat with 2j hat, to get a final result equal to 8I hat plus 7j hat.